Assalamualaikum and hi students. So let's review the answer for tutorial week 1, which discuss subtopic 1.1 reaction rate. The first question is write the differential rate equation for the following reactions. So firstly, you must understand what is differential rate equation. Differential rate equation shows the relationship between the rate of disappearance of reactants and rate of formation of products. So in order to write the differential rate equation for, let's say for example, for the first question 1a, right? So you have to refer to the stoichiometrical coefficients written in the balanced chemical equation. So you must start with rate. Alright, so this is the answer for question 1a. So you can see here, you must start with the word rate. Okay, and you can see this differential rate equation relates the rate of disappearance of reactants. So the reactants are iodide ion and OCl minus ion. So negative shows that negative sign shows that reactants decrease with time. The concentration of reactant decrease with time. The positive sign shows that the concentration of product increases with time. Right? So this is the first answer. The answer for question 1a. And this is the differential rate equation for question 1b, where you can see here 3 here is come from the stoichiometrical coefficient or stoichiometric coefficient, and same goes to 2 here. So that's why you have to refer to the balanced chemical equation given in the question. And this is the differential rate equation for question number 1c. So please check your answer. Alright, don't forget to write down the positive sign. It is compulsory. Alright. Okay, so I think there is no issue here, right? Okay, so next we go to the question number 2. Okay, consider the reaction. 4 mole of ammonia reacts with 5 mole of oxygen gas, produces 4 mole of nitric oxide and 6 mole of water vapor. And the disappearance of rate of oxygen is 0.020 molar per second. Determine the formation rate of water and determine the disappearance rate of ammonia. Alright, so firstly, for question number 2a, alright, question 2a, the question asks you to determine. Determine means you have to calculate the formation rate of water vapor. So, just now, I said that the differential rate equation relates the rate of disappearance of reactants and rate of formation of product. So, differential rate equation ni dia menghubungkan kadar pengurangan reactant dan kadar pembentukan produk. So, what you are going to do is, firstly, you must write the differential rate equation for the whole reaction. So rate equals to -1/4 the concentration of ammonia over dt equals to -1/5 the concentration of oxygen gas over dt equals to +1/4 the concentration of nitric oxide over dt and equals +1/6 the concentration of water vapor over dt. Alright. So now let's start to answer question 2A. The question asks you to determine the formation rate of water vapor. Alright. So, firstly, you have to compare the rate that we want with the one that already given in the question. You have to compare rate that we want with the one that already given in the question. So, in the question, given to you the rate of disappearance of oxygen gas. So it is negative D. So it is negative D concentration of oxygen gas over dt, which is equal to 0.02 molar per second. So that is given to you in the question. And now compare rate that we want with the one that already given in the question. So given in the question is the rate of formation of oxygen gas. Alright, so this is given to you. This is given to you. Okay, so how we are going to compare? How we are going to compare the rate of what we want and with the one that we have in the question. Okay, so please look, please refer here. So we have this one, and we are going to relate with this one. Alright, okay. So compare the rate that we want. Positive 1/6 the concentration of water vapor over dt, which is equals negative 1/5 the concentration of equals negative 1/5 the concentration of oxygen gas over dt. Alright, we are going to determine the rate of formation of water vapor. We are going to calculate this one, the rate of formation of water vapor, which is equals to 6/5 times the concentration of oxygen gas over dt, or you can simplify it where you can write down like this to make it easier for you. Rate of formation of water vapor equals to 6/5 times the rate of disappearance of oxygen gas. Okay, apa maksudnya? Sekarang kita nak kira rate of formation of water. So, ini kita sebut sebagai rate of formation of water vapor. Okay. Ini yang saya bulatkan ini, kita sebut dia sebagai rate of disappearance of oxygen gas. Jadi apa hubung kait dia? Kadar pembentukan water vapor adalah 6/5 kali ganda daripada kadar pengurangan oksigen gas. Alright, so you can see here. Alright, so now what you are going to do? Okay, you are going to substitute the values given in the question. So rate of formation of water vapor over dt is equals to 6/5 times the value of rate of disappearance of oxygen gas given in the question, 0.02 molar per second. Alright, so selesaikan. Suppose you will get the answer 0.024 molar per second. So, apa maksudnya? Thus, rate of formation of water vapor is 0.024 molar per second. Dalam masa 1 saat, sebanyak 0.024 molar water vapor terhasil. Alright, so what I want to emphasize or stress here is the value of the rate. The value of the rate must be positive. This cannot be negative. Jadi saya dah tunjukkan dalam slide ini macam mana kita nak cara kita menulis differential rate equation itulah sebenarnya yang menunjukkan, yang menyebabkan kita boleh dapat nilai rate itu positif. Macam mana? Yang ni yang saya memudahkan ni. Kita bawa sebutan 6/5 ke depan. So rate of disappearance tu kita kurungkan dia, dan negative sign jangan lupa. So memang you akan dapat negative value kat sini. Okay, siapa yang dia bawa negatif kat depan, lepas tu dia akan dapat nilai rate tu negatif. Bila you tulis jawapan tu, rate itu sebagai negative value, memang salah, takkan diterima. Okay class? Okay, so settle with question A. Alright, same method to solve question 2B. Okay, where you are going to calculate the rate of disappearance of ammonia. Alright, okay. So since given to you in the question the rate of formation of oxygen gas, so now you are going to compare the rate that we want, which is the rate of formation of ammonia with the rate of disappearance. Sorry, you are going to compare the rate of disappearance of ammonia and compare with the rate of oxygen gas, which is given in the question. So write down here -1/4 the concentration of ammonia over dt equals -1/5 the concentration of oxygen gas over dt. Alright, okay, so sebelum saya terlupa, pastikan bila you menulis differential rate equation ni, you use the correct brackets. Okay, you must use square bracket to show the concentration. Kalau you salah guna kurungan, salah, memang tak diterima. Alright, so now you are going to determine the rate of disappearance of ammonia, where the rate of disappearance of ammonia is equals to 4/5 times the rate of disappearance of oxygen gas. Maksudnya apa? Kadar pengurangan amonia adalah 4/5 kali ganda daripada kadar pengurangan oksigen gas. Okay, so now substitute the value 4/5 times 0.02 molar per second. Alright, okay, thus you will get the rate of disappearance of ammonia is around 0.016 molar per second. Right, you can see the value of the rate still lagi positif. Tak ada tanda negatif pun sebab nilai rate mesti positif. Tak boleh negatif. Okay, do not leave your answer with that value only. So, I suggest to you write a statement. Okay, write a statement. Rate of disappearance. Okay, rate of disappearance of ammonia is 0.016 molar per second. Maksudnya apa? Kadar pengurangan amonia adalah dalam masa 1 saat dia berkurang sebanyak 0.016 molar. Alright? Okay. Next question. Question number 3 for face-to-face question. Alright class, in the first question, you are going to calculate the rate of formation of ammonia. So, write down, firstly, you must write the differential rate equation for the whole reaction. Right, like this. And given to you in the question, the rate of molecule of hydrogen, given to you in the question, the molecule of hydrogen is reacting at the rate of 0.074 molar per second. So that is the rate of the disappearance of hydrogen gas. Equation A, you are going to determine the rate of formation of ammonia. So, compare. From the differential rate equation, compare the rate of formation of ammonia. Okay, so this is the rate of formation of ammonia from the differential rate equation, and this is the rate of disappearance of hydrogen gas from the differential rate equation. Okay, so we write here negative 1 over 3 d concentration of hydrogen gas over dt equals to positive 1 over 2 the concentration of ammonia over dt. Since we are going to calculate the rate of formation of ammonia later on, so to make it easier for you, I change the position of rate of formation of ammonia and rate of disappearance of hydrogen gas. So saya tulis yang ammonia tu sebelah kiri sebab kita nak cari dia. So positive 1 over 2 rate of formation of ammonia over dt equals negative 1 over 3 negative 1 over 3 rate of disappearance of hydrogen gas. But actually you are going to determine the rate of formation of ammonia. Bila soalan kata calculate the rate of formation ke rate of disappearance ke, maksudnya tanpa stoichiometric coefficient daripada equation. Okay, so rate of formation of ammonia is 2 over 3 times the rate of disappearance of hydrogen gas. Kadar pembentukan ammonia adalah 2/3 kali ganda daripada kadar pengurangan hydrogen gas. So ini nilainya. So now substitute the value. So 2 over 3 times 0.074 molar per second. Okay, tak muat, so saya bawa sebelah sini ya. So saya bawa sebelah sini lah jawapan dia. Alright, so the rate of formation of ammonia is lebih kurang 0.049 molar per second. So you can see the rate value is positive. Rate value mesti positif. Tak kisahlah bagi rate of formation ke, bagi rate of disappearance ke, mesti nilainya positif. Okay, do not leave your answer with that value only. So I suggest to you write a statement. Okay. Rate of formation of ammonia is 0.049 molar per second. Maksudnya ammonia ni terhasil dalam masa 1 saat sebanyak 0.049 molar. Alright, so that is for question 3A. Alright, for question 3B, you are going to calculate the rate of depletion of nitrogen. So depletion sama maksud dengan disappearance. So you are going to calculate the rate of disappearance of nitrogen gas. And since given to you the rate of disappearance of hydrogen gas, and since given to you the rate of disappearance of hydrogen gas, so we are going to compare the rate of disappearance of nitrogen gas and rate of disappearance of hydrogen gas from the differential rate equation. So rate of disappearance of nitrogen gas over dt, okay, equals to 1 over 3 the rate of disappearance of hydrogen gas. Alright, thus you can see here, okay, the rate of disappearance of nitrogen gas is 1 over 3 times the rate of disappearance of hydrogen gas. Alright, this is hydrogen gas. Okay, substitute the value. So the rate of disappearance or rate of depletion of nitrogen gas is 0.025 molar per second. And still you can see the rate value is a positive value. Alright? Okay, write a statement. Thus, the rate of depletion of nitrogen is 0.025 molar per second. Okay, class? So, this is for differential rate equation. So, differential rate equation, it compare the rate of disappearance of reactant and rate of formation of products. Okay. Now, continue with the tutorial second hour with non-face-to-face question. Okay, determine the unit of rate constant. Sketch the graph of rate of reaction versus concentration of A for 0, first and second order. Okay, so you boleh buat macam-macam cara lah sebab dia minta graph. Yang pertama dia minta unit of rate constant, and then graph rate of reaction against concentration. So kita boleh buat dalam bentuk table ataupun tak ada bentuk table pun tak apa, kita buat satu-satu. Okay, so okay, alright, so firstly, since you are going to determine the unit of rate constant, right, so we have to refer to the rate law. So to write the general rate law, okay, we have to refer to this information. Okay, so this reaction involve only one reactant. So the rate law is, let's say it is a zero order reaction. Rate equals to K times A concentration. Rate equals to K times concentration of A power of 0. Thus rate equals to K. So this is called rate law. Rate law relates the rate of the reaction, rate constant, and concentration of reactant or reactants at certain temperature. So this is the rate law for zero order if we refer to this reaction. Okay, so how to determine the unit of rate constant? So you must know the unit of rate. The unit of rate is molar per second. Unit bagi rate adalah molar per second. So kita boleh dapat unit rate constant bagi zero order. Maksudnya kita tak perlu nak hafal pun, kita boleh derive sendiri. Thus the unit of rate constant for zero order is molar per second. Alright, settle for zero order. So now let's move to first order. If this reaction, if A undergoes first order reaction, thus the rate law equation is rate equals to K times concentration of A. So tak payah buat power of 1. Understood? Ini adalah first order. Alright, okay, so now let's derive the unit of K or the unit of rate constant. Molar per second equals to K times the unit of concentration. Let's say we use molar. Alright, molar. So molar is cancelled out. Thus the unit of rate constant for first order is per second. Kalau ianya diukur dalam unit second, boleh jadi dia diukur dalam unit minit dan sebagainya. And same goes to the concentration. It can be measured in molar or mole per decimeter cube unit dia. Okay, so kena bijak di situ. Alright, if A undergoes second order reaction, the rate law is rate equals to K times concentration of A power of 2. Right? Okay, so now let's derive the unit of rate constant for second order. Molar per second equals to K times molar times molar. So molar and molar is cancel out. So bawa M tu turun ke bawah, plus the unit of rate constant K is per molar per second. Alright, next, sketch the graph's rate of reaction against concentration of A. Alright, if the reactant follows second order reaction, okay, so you can see here, if you increase the concentration of A, no matter how many times you increase the concentration of A, the rate remain constant. So this is the graph. Alright, okay. For first order reaction, you tengok dekat sini, if the concentration of reactant A increase, the rate will increase. Kalau concentration of A bertambah 2 kali ganda, rate akan bertambah 2 kali ganda. So yang ini saya dah discuss ataupun saya dah tunjukkan dalam video dalam YouTube saya yang telah di-up di YouTube, rate law. Okay, so the graph is like this. For second order reaction, you can see here, if the concentration of A is double, rate becomes quadruple. Kalau concentration A dinaikkan ataupun bertambah 2 kali ganda, jadi nilai rate akan menjadi 4 kali ganda. Kalau concentration of A bertambah 3 kali ganda, nilai rate akan bertambah 9 kali ganda. Kalau concentration A bertambah 4 kali ganda, maka rate akan bertambah 16 kali ganda. So the curve or the graph is looks like this. Dia exponential. Dia separuh parabola. Okay. Alright. So it is very easy. Sepatutnya ni tak ada masalah. Okay. So now let's move to question face to face. The reaction below is second order for nitric oxide and first order for chlorine molecule. By what factor does the rate increase if each of the following changes occur? Alright, so let's refer to question 2a. So firstly, to answer this question, because given to you the reaction order for each reactant, you have to write the rate law. Okay, the rate law is rate equals to K times concentration of nitric oxide. Since nitric oxide is second order, it is power of 2 times concentration of chlorine molecule. So it is first order, tak payah tulis power of 1. Okay, so now by what factor? Berapa kali gandakan ataupun berdasarkan berapa faktor rate itu akan bertambah kalau both concentration NO and chlorine is doubling ataupun is double. Okay, if we doubling the concentration of NO and chlorine molecule. Okay, macam mana nak buat? Okay, so rate, kita nak kira rate, kita nak tentukan rate ni sekarang. Kita nak predict rate tu akan increase berdasarkan berapa faktor, right? So K remain constant, tulis times concentration of NO is double, 2 NO power of 2 times, and also concentration of chlorine gas is double. Alright, okay, so 2 power of 2 is equal to 4, right? And 2 power of 1 kat sini tak payahlah, kita dah jelas. So 2 kuasa 2 4, 4 kali 2 8. So you can see here 8K times concentration of NO power of 2 times concentration of chlorine. So this is rate after the concentration of both reactant is double. Okay, jadi kita tak boleh tinggal macam ni je. kita tak boleh tinggal jawapan tu macam ni je. Jadi awak tengok dekat sini ada faktor 8. You have to write thus the rate increase by factor of 8. Dalam erti kata paling mudah, the rate increase 8 times. Dalam erti kata paling mudah, kadar tindak balas ini bertambah sebanyak 8 kali ganda kalau kita lakukan perubahan concentration seperti soalan A. Okay, question B, making chlorine concentration 3 times higher. So NO remain constant. So firstly, write the rate law equation. Rate equals to K times concentration of NO power of 2 times concentration of chlorine gas. So now the concentration of chlorine is increased 3 times higher from the previous reaction. So rate equals to K. NO kita tak kacau, remain, tulis. So kat sini naik 3 kali ganda. Alright, so kalau kita selesaikan secara matematik, 3K times concentration of NO power of 2 times concentration of chlorine gas. So what happened to the rate? Thus, the rate is increased by factor of 3. So kadar tindak balas bertambah sebanyak 3 kali ganda ataupun berdasarkan faktor 3 lah. Okay. Question C. Making concentration of NO 3 times higher while halving concentration of chlorine gas. Okay, dalam soalan sini dia kata concentration NO increase 3 times higher while the concentration of chlorine is half. Berkurang menjadi separuh. Okay, alright. Ataupun bertambah separuh lah. Separuh je bertambah. Dia bukan bertambah sekali ganda ke apa. Okay, jadi kita selesaikan 3 power of 2 9 divide by 2 4.5. So rate equals to 4.5 K times concentration of NO power of 2 times concentration of chlorine gas. The rate increase by factor of 4.5. Okay, so that is the second question for second hour face to face, week 1. So this is the face-to-face question for second hour, right? Okay, so let's read the question. The conversion of cyclopropane to propene in the gas phase is a first order reaction with the rate constant of 6.7 times 10 to the power of -4 per second at 500 degrees Celsius. If the initial concentration of cyclopropane was 0.25 molar, calculate the concentration after 8.8 minutes and determine the fraction of cyclopropane has decomposed in this time. Okay, if you refer to the question, dia dah beri awak apa reactionnya dalam bentuk statement, what type of order, this first order, and given to you the rate constant at certain temperature pada suhu 500 degree Celsius. Okay, jadi kita ada concentration of the reactant which is the cyclopropane. Walaupun dia tak mention berapa, tapi kita dah tahu siapa reactantnya, the order of the reaction and the rate constant. So when you are going to solve the question, kalau you tengok soalan A, B, C, dia ada sebut faktor masa. Okay, ada sebut faktor masa, and then ada pula sebut concentration initial ke after tea time ke. Maka di sini kita akan relate dengan integrated rate law because there is time factor there. Contoh nampak disebut 8.8 minit. How long will it take for? Maksudnya berapa lama? Itu adalah masa. Calculate the time taken. Nampak faktor masa. Jadi kita nak relate time dengan rate of reaction, kita akan gunakan integrated rate law. Alright, integrated rate law. Okay, so how to solve the first question? Okay, kalau you tengok pada soalan ayat atas ni, dia sebut the conversion of cyclopropane to propane. Okay, so the reaction is occur. The reaction occur is the decomposition of cyclopropane. So cyclopropane is the reactant. This converted to propane. Right, so this is the equation actually, the reaction. Okay, and then given to you the rate constant K for this reaction to occur, 6.7 times 10 to the power of -4 per second. So mentioned in the question, the reaction, the conversion of cyclopropane to propane is first order. Kalau soalan tak beri tahu order apa, kita tengok pada unit rate constant. So per second kat sini menunjukkan dia adalah first order. Betul lah tu. Okay, so now question A, you are going to calculate the fraction of cyclopropane has decomposed. If the initial concentration of cyclopropane was 0.25 molar, so initial concentration of cyclopropane 0.25 molar. Okay, calculate the concentration after 8.8 minutes. So we are going to calculate the concentration of cyclopropane after tea time. After tea time tu adalah selepas 8.8 minit, berapakah concentrationnya? So we don't know. Right? Okay. So since we know the time given in the question is 8.8 minute. Okay, 8.8 minute. Right? And we have to make sure the unit of time and the unit of time in the rate constant adalah sama. So sekarang ini minit, ini per second. So unit tak sama. Maka paling mudah kita akan convert 8.8 minit ini kepada second. Alright, jadi kena kira dulu 8.8 minit tukar kepada second. So 8.8 minit is equivalent to 528 second. Tukar sendirilah. Okay. So now, since it is first order reaction, since the reaction is first order reaction, and now we are going to calculate the concentration of cyclopropane after 8.8 minutes. We are going to use the integrated rate law for first order. Right. What is the formula? Ln initial concentration of cyclopropane divided by the concentration of cyclopropane after 8.8 minutes, which is equal to KT. Since the question dah beritahu siapa reaktannya, kita tak boleh guna ln initial concentration of A bahagi concentration of A at T time. Kita kena ganti siapakah reaktannya. And now we are going to calculate, we are going to substitute the values. Alright, so ln 25 -8 ln 0.25 divided by concentration of cyclopropane at T time equals to KT. So equals to KT. So K value is 6.7 times 10 to the power of -4 per second times time in second, 5 to 8 second. So the unit of second and per second is cancelled out. Alright, selesaikan. You will get the concentration of cyclopropane after 8.8 minutes around 0.1755 molar. So this is the answer for the first question in question 3A. Alright. And the question asks you to determine the fraction of cyclopropane has been decomposed in this time. Berapakah pecahan cyclopropane yang telah terurai in this time? Okey, sekali lagi saya nak ingatkan yang ini concentration at T time ni adalah yang wujud selepas 8.8 minit. Tapi dalam soalan A yang kedua ni, determine the fraction of cyclopropane has decomposed. Tentukan pecahan cyclopropane yang telah mengalami penguraian. So dia tak sama dengan yang dimin ataupun yang wujud pada 8.8 minit. Alright, jadi sekarang ni macam mana kita nak jawab? Okey, so maksudnya kita kena carilah yang telah mengalami penguraian tu dengan initial concentration. Maksudnya selepas 8.8 minit, maksudnya 8.8 minit itu yang tinggal selepas proses decomposition. Okey, so kalau kita nak kira berapakah yang telah decompose, maksudnya concentration of cyclopropane at T time bahagikan dengan initial concentration. Jadi kat sini concentration of cyclopropane at T time divided by initial concentration of cyclopropane. So 0.1755 molar divided by 0.25 molar. Jadi kita dapatlah pecahan berapa yang telah decompose. So around 0.702. Alright, settle with question 3A. So now look at question 3B. How long will it take for the concentration of cyclopropane to decrease from 0.25 molar to 0.15 molar? So actually soalan ni sedang aja. Alright, so question B, given to you initial concentration of cyclopropane is 0.25 molar. After T time, the concentration of cyclopropane after T time is 0.15 molar. The concentration of cyclopropane decrease from 0.25 molar to 0.15 molar. Asalnya 0.25 molar, selepas satu masa, it becomes 0.15 molar. So the rate constant still remain because the temperature remain constant. And now we are going to calculate time. Since we are going to relate the time with the rate of reaction and concentration, okay, so we are going to use differential rate equation. So ln initial concentration of cyclopropane, write the formula first, divide by concentration of cyclopropane at T time equals to KT. Right? So ln 0.25 divided by 0.15 equals to K, which is 6.7 times 10 to the power of -4 per second, right? And the time we are going to calculate is T. Okay, selesaikan, maka you akan dapat T after T time, the time taken is around 762.43 second. So kita akan dapat dalam unit second lah sebab kat sini per second. Okay. So soalan tak suruh tukar kepada minit, maka you tak perlu tukar kepada minit. Alright. Okay. Calculate the time taken to convert 74% of the starting material to propane. Okay, for this question, since given to you in a form of percentage, dia beri awak dalam bentuk percentage. Therefore, we assume that the initial concentration of cyclopropane is 100% or 100. And after T time, the concentration becomes 100 minus 74. Right? 100 minus 74. Which is 26. 74% ni yang mengalami penguraian. So yang wujud selepas dia terurai adalah 26. Alright? Okay. So by using the integrated rate law, ln initial concentration of cyclopropane divide by concentration of cyclopropane at T time equals to KT. So we can calculate the time taken. Alright, so here is ln 100 divided by 26 equals to K 6.7 times 10 to the power of -4 per second times time T. Alright? Okay. So solve these problems. So you will get the time taken. It is around 2010.56 second. Okay. So for third hour non face to face, I'm not going to discuss the question very detail sebab dia lebih kurang sama macam first face to face second hour. Okay, cuma saya akan highlight sikit-sikit lah perkara-perkara yang penting. Alright, so firstly for this reaction, this question, kalau you lihat, is given to you a reaction, this reaction, and it is second order for nitrogen oxide and first order in bromine. Given to you the rate constant and the concentration of nitrogen oxide and the concentration of bromine. Okay, calculate the value of K. Since we have the order of the reaction, order of each reactant, okay, to the reaction, we have the rate constant and we have the concentration of each reactants. Therefore, to answer question A, you have to refer to the rate law. So write down the rate law first. Rate equals to K times concentration of NO power of 2. Mana datang power of 2? Sebab dia dah mention dalam soalan second order in nitrogen oxide times concentration of bromine. Since bromine adalah first order, tak payah buat power of 1 kat sini. Okay, jadi sekarang kita nak cari dia punya rate constant K. Alright, and given to you the rate of the reaction. Dia dah beri dalam soalan. So this is the rate of reaction, which is 1.6 times 10 to the power of negative 8. This is the nitrogen oxide concentration, and concentration of bromine is 0.030 molar. So nak kira K, kita ganti ke dalam rate law equation. Okay, so rate is 1.6 times 10 to the power of negative 8, okay, molar per second, times K, concentration of nitric oxide is 0.20 molar power of 2, times concentration of bromine 0.30 molar. So molar is cancelled out. So here is molar squared. This one is per second. So selesaikan by using mathematics. Therefore, you will get the rate constant value. Thus, the value of K is around 1.33 times 10 to the power of negative 3 per molar power of negative 2 per second. So that is for question A. Okay. If the rate is 3.5 times 10 to the power of 7 mole per liter, alright, okay, and the concentration of nitric oxide or nitrogen oxide is 0.043 molar, calculate the concentration of bromine. Okay, so you kena faham kat sini, reaction ini semua ni berlaku pada suhu yang sama. Jadi kalau berlaku pada the same temperature, the value of K remain constant. Okay, for question B. Alright, question B, we have to refer to the rate law again, the rate law equation. Right, the rate is 3.5 times 10 to the power of 7. Okay, there is a typo there. Actually, this one is negative 7 ya kelas. 10 kuasa negative 7 sepatutnya. Okay. Negative 7 molar per second equals to K. Okay, we have the K value. Okay. Alright, so selesaikan. Bila you selesaikan, actually you will get the value of concentration of bromine around 0.142 molar. And for question C, if the rate of reaction is 2.0 times 10 to the power of negative 6 mole per liter per minute, and the concentration of bromine is 1/4 of the concentration of nitrogen oxide, determine the concentration of nitrogen oxide. Okay, dia tak bagi maklumat apa-apa concentration, dia hanya bagi rate sahaja. Okay, tak apa, kita refer pada rate law equation. Rate equals to K times concentration of nitric oxide times bromine molecule. Okay. Okay, so rate is given. Rate is 2.0 times 10 to the power of negative 6 molar per second. Okay. And the rate constant is 1.333 times 10 to the power of negative 3 molar power of negative 2 per second times concentration of nitric oxide, okay, power of 2, and times concentration of bromine. So concentration of bromine now is 1/4 daripada concentration of nitric oxide. Dah sebut dalam soalan. So 1/4 concentration of nitric ataupun nitrogen oxide. Okay, jadi selesaikan secara matematik. Okay, for question 2, non-face to face. Right, the rate constant for the above reaction is 7.0 times 10 to the power of 9 per molar per second. So given to you the rate constant. If the initial concentration of iodine atoms is 0.086 molar, calculate the concentration after 2.0 minute. Alright. In this case, the question did not mention the order of the reaction. You have to determine the order of the reaction from the unit of rate constant here. So since the unit of rate constant is per molar per second, thus the reaction is second order. Right? Okay. So now since you are going to calculate the concentration after 2.0 minute, we are going to use the integrated rate law for this reaction. Right? So the integrated rate law for second order is generally is 1 over A. So kita tak boleh masukkan 1 over A sebab kita dah tahu siapa reaktannya ni. Okay. So the formula is 1 over concentration of iodine gaseous atom at T time equals to 1 over initial concentration of iodine plus KT. Okay. Alright. So since we are going to calculate the concentration of iodine gaseous atom after 2.0 minutes. Alright. Okay. So kita akan kira kat sini. The 1 over initial concentration is 0.086 molar. Okay. Plus. Okay. The rate constant is 7.0 times 10 to the power of 9 per molar per second. Okay, time stated in the question 2.0 minute, but the unit of time in the rate constant is per second. So convert 2.0 minute to second. So it is 120 second. Alright, okay. So times 120 second. So second and per second is cancelled out. Okay. Okay, class. Thus, the concentration of iodine at T time is 1.2, around 1.2 times 10 to the power of negative 12 molar with unit. Tak ada unit salah. Jadi rate constant mesti ada unit. Concentration yang kita kira mesti ada unit. Rate pun mesti ada unit. Okay, kalau tak ada unit, tak ada maknalah pengiraan awak tu. Okay. Alright. Non-face to face. Question 2B, the question asks you about half-life. Half-life of iodine atoms if the initial concentration diberikan dalam soalan. Okay, first of all, you kena tahu apakah formula half-life bagi second order. Right? So for second order, the half-life is, alright, 1 over K times concentration of the reactant, the initial concentration of the reactant. And since the reactant is iodine gaseous atom, kita kena tulis kat sini. Right? Okay, so for question 1A, half-life 1 over K. So the K value is 7.0 times 10 to the power of 9. Okay. Molar power of negative 2 per second times the concentration, the initial concentration of iodine, which is 0. So substitute the values. Alright, so the rate constant and the initial concentration. So you can see molar and per molar is cancelled out. Plus the half-life for question 1, actually 1, right, is around 3.4 times 10 to the power of negative 10 second. And for question 2, by using the same procedures, okay, please check your answer. Suppose the answer is 2.4 times 10 to the power of negative 10 second. Okay. So now let's move to the face-to-face question, third hour. Okay, you were given a set of data. There are 3 readings. The reaction is repeated 3 times. Okay, the reaction was repeated 3 times. So what is there? What do you have? So what do you have? We have the reaction rate. We have the concentration of each reactants. Okay, the first question is determine the order with respect to each reactant. Bila soalan tanya the order of reaction ataupun the order of each reactant, bila soalan tanya the order with respect to each reactant, okay, dan kita ada a set of data seperti ini, minimum 3 data, kita ada reaction rate, kita ada concentration of reactants, maka untuk menyelesaikannya kita akan gunakan kaedah yang dipanggil initial rate method. Okay. Bila kita nak gunakan initial rate method, kita akan guna compare rate dan kita akan refer kepada rate law juga. Okay, macam mana nak buat? First sekali, kita refer kepada balance equation ini. So, write down the rate law equation yang mana kita tak tahu dia punya order. Tak apa, kita tak tahu dia punya order, tak apa. Kita nak kira order tu lah. Tapi kita kena gantikan dengan reactant sebenar. Rate equals to K times concentration of the first reactant, 2-chloropropane. So, ganti tuliskan, jangan malas. Times concentration of sodium hydroxide. Okay, tapi sekarang kita nak cari order ni. Jadi kita assume order with respect to 2-chloropropane ni adalah power of X. This one is power of Y. Okay, jadi dengan menggunakan data-data ini, we are going to determine the order of each reactant. Okay, so let's say I want to calculate the order with respect to 2-chloropropane. Saya nak kira untuk yang ini dulu. Okay, saya nak kira untuk yang ini terlebih dahulu. Jadi macam mana caranya? Okay, caranya kita lihat kepada data di atas. Kita kena cari daripada mana-mana eksperimen. We have to compare the rate where the concentration of sodium hydroxide are same. Supaya kita boleh cancel out. Okay, kalau you tengok kat sini, concentration sodium hydroxide yang sama yang kita boleh cancel out adalah pada data eksperimen 1 and eksperimen 3. Okay, jadi kita akan compare the rate dulu. So, compare rate eksperimen 3 terhadap rate eksperimen 1. Okay, jadi actually kita sebenarnya menggunakan rate law ni, kita compare the rate. So, rate eksperimen 3 is equal to K times the concentration of the reactant, 2-chloropropane, right? Power of X times concentration of sodium hydroxide, power of Y. Sama juga dengan yang bawah ni. Kita akan tulis dia punya rate law tu juga. Concentration of reactants. Since experimental data from experiment 3 and 2 was chosen, okay, kita akan gantikan nilai dia. Jadi rate from experiment 3 is 9.0 times 10 to the power of negative 3 molar per second divide by 3.0 times 10 to the power of negative 3 molar per second. Okay, K kita tak tahu nilai, so tak apa, tulis jenis simbol K. Okay, concentration of 2-chloropropane for experiment 3 is 0.45 power of X times concentration of sodium hydroxide from experiment 3 is 0.25 power of Y. And same method for experiment 1. The concentration of 2-chloropropane is 0.15 power of X times concentration of sodium hydroxide 0.25 power of Y. So, K and K is cancelled out. The concentration of sodium hydroxide also cancel out. The unit of rate also cancel out. So, kita akan selesaikan guna matematik. Right, kita selesaikan guna matematik. Maka kita akan dapat di sini masukkan nilai, you selesaikan guna matematik, sepatutnya you akan dapat nilai X. Alright, X equals to 2. Do not leave your answer with X equals to 2. Kita bukan mengira nilai X, kita sebenarnya mengira order. So, buat satu statement. Okay, buat satu statement. Plus the reaction. X is equal to 1. But since we are going to determine the order of the reaction, do not leave your answer with X equals to 1. You kena buat satu statement. Thus, the reaction order, the reaction is first order in this reactant. Barulah dia akan tengok kat sini. Okay, biasanya dia akan tengok pada general rate law. Okay, lepas tu penggantian ini masih betul. Lepas tu dia akan tengok yang kat bawah ni. Jadi nak tak nak memang kena kira dulu X. Lepas tu baru kita tengok first order tu. Okay. Okay, for question B. Since saya nak cari order terhadap sodium hydroxide. If we refer to the rate law, so, I will choose experimental data from experiment 2 and experiment 1. So, rate substitute the values. So, kenapa saya pilih data eksperimen 2 dan eksperimen 1? Sebab saya nak concentration 2-chloropropane, reaktan yang pertama tu constant supaya saya boleh cancel out. Jadi, yang ini kita berbeza kan? Jadi, kita boleh selesaikan secara matematik. So you can see here the unit of rate is cancelled out, K is cancelled out, this one is cancelled out. So sekarang tinggal yang ini sahaja. So yang ini kita akan selesaikan dengan rate sebelah sini. Okay. So solve by using your mathematics knowledge, you will get Y is equals to 1 plus the reaction is first order in sodium hydroxide. Sekali lagi saya ingatkan kena tulis ini, kena tunjukkan semua step ini dan jangan biarkan dengan ini sahaja. Kena tulis statement untuk kita menunjukkan order tu apa. First order ke second order. Okay, so now question B. Write the rate equation. Since we have already determined the value of X and Y, where X and Y are the order of the reaction. Okay, so kita kena tulis yang asal lah sebab soalan minta pun. Kalau tak minta pun kita kena tulis. So, rate equals to K times concentration of rate equals to K times concentration of 2-chloropropane CCT's first order tak payah buat power of 1 times concentration of sodium hydroxide. Sama juga. Yang ini pun adalah first order, tak payah buat power of 1. Okey kelas, so saya nak awak check semua jawapan tu. Kalau ada masalah bagi tahu saya. Mana yang salah tolong betulkan. Tanda jawapan masing-masing. Okey kelas, thank you.